All right, it's time to tackle your help video for quiz 5.06. Okay, so here's your need to know info. I actually put more than we need to know on here, but that can't hurt. So some stuff that we learned a long time ago about scale factor. The first thing that you do need to know is that it's the image over the pre-image. You're definitely going to need that formula. This is some more stuff that I just want to review. You don't necessarily have to have for this quiz, but remember, if the absolute value of the scale factor is greater than 1, it's getting bigger. If the absolute value of the scale factor is between 0 and 1, it's getting smaller. And negative scale factors do not determine if it gets bigger or smaller. They change the orientation. And then, of course, our mapping rule, we would multiply our x and y times our scale factor. All right, here's something else that you need to know. If you are given a scale factor and want to know the next larger scale size, you're going to multiply it by the scale factor. If you're given a scale factor and you want to know the next smaller scale size, you're going to divide it by the scale factor. And then we also are going to talk about maximizing volume. I thought that this was just a really cool image to show you that depending on how you cut your paper, you could have different size volumes. And we're trying to figure out how do we cut the paper so that we have the most volume possible. All right, and this is how we're going to do it. What this represents right here is if this entire length of this side is 8 units, then you would need to cut off this corner and this corner up here, like where they have that white part. We're cutting that off so that we can fold it up to create a box. And so we're just going to let those be X because we don't know, if it's going to maximize the volume at 1 or at 2 inches or at 3 inches. That's what we're trying to figure out. We're trying to figure out how to maximize that volume. So we're just going to leave that as an X. So to get this new length that you fold up, let me highlight here. To figure out this length that ends up being right here, you would take your full distance 8 and you would subtract off 2 x's because you're cutting off an x from each side. And then you do the same thing over here. If your full distance is 4, you want to cut off those 2 x's. So this would be represented as 4 minus 2x. And then the height, of course, is what you fold up, which would be x. So if I wanted to try to maximize the volume of this example, I would do length times width times height and solve for x. So we're going to be tackling that as well. The first question says, 4 sizes of a scaled text are shown. What is the unknown scale size? So we're trying to figure out this scale size. Now we do know, just by looking, it's getting bigger. So we do know it has to be something greater than 1. So let's go ahead and tackle this. We're looking for scale, the unknown scale size. So we need to figure out the scale factor. And remember, the scale factor formula is image over pre-image. So I'm going to figure out the scale factor. I'm just going to take, I'm going to use these two. I started with this one, so that's my pre-image, and I ended with this one, that's my image. So I'm going to throw that over here into my scale factor formula. My image divided by my pre-image. And when I divide those, I get approximately 1.06719, yada, yada, yada. So that's my scale factor. Well, we want to know the next larger size after 1. So we would take 1 and we would multiply it by that scale factor because we want to know the next larger size. So we would take 1 and we would multiply it by our scale factor, which of course is anytime you multiply 1 by something, it stays the same. So the next larger size would be 1.067. All right, for a certain font, the scale factor is this. That's kind of cool. They already give us the scale factor. And one of the scale sizes is 1.99. What is the next larger size? Okay, so if we want to make it bigger, we're going to take our size and we're going to multiply by our scale factor. So if we multiply this out, we would get let's see, 2.826586. And it says round to the nearest thousandths. Remember, 1,000 has 3 zeros, which means we want to go 3 decimal places. So we look at the number behind it, and that 5 is going to make that 6 jump up to a 7. You do have to make sure that you round correctly for the OHS to give you credit. All right, for a certain font, the scale factor is 1.33. Again, they already give us the scale factor. And one of the scale sizes is 2.353. What is the next smaller scale size? So if we want to make it smaller, we have to divide. So we're going to take our scale size, and we're going to divide it by our scale factor. And so my calculator tells me 1.769172, woo, all these numbers. And it says round to the nearest thousandths. 1,000 has 3 zeros, so we want 3 decimal places. Look at the number behind it, and that 1 is going to keep that 9 the same. So it's going to be 1.769 will be the next smaller scale size. All right, so now we're talking about maximizing the volume. It says a box without a top is made from a rectangular piece of cardboard with dimensions of 4 by 2. By cutting out square corners with side lengths x, which expression can be used to determine the greatest possible volume of the cardboard box? So here's our image down here. This is what's happening. This full length is 4. This length is 2. But again, we're cutting out the corners. So we're cutting out an x from each side. So this full length becomes 4 minus 2 x's. This length becomes 2 minus 2 x's. And then the height here becomes an x. So if we want to maximize the volume, remember volume of a rectangle is base, or length times width times height. I'll use length times width times height. Length times width times height. So we would just take our length times our width times our height. And that would be the formula we would use to try to maximize the volume. And it just wants to know the formula, so that is the correct answer. All right, so the next one. Claire has 60 yards of fence with which to build a rectangular pigsty. What is the maximum area she can enclose? Okay, so I forgot to include need to know information on this, but an area of a rectangle is base times height, or you can consider it length times width, either way. So let's go ahead and sketch a picture here. We have a rectangle. We don't know what our side lengths are going to be. That's what we're trying to figure out. So I'm just going to let this side be x. Now, since it's a rectangle, if I let this side be x, I know the opposite side has to also be x. And I know that my total amount of fence is 60 yards. So to figure out what the other lengths would have to be, I would take my 60 and I would subtract off the 2 x's that I've already used, right? I've used an x for this side and an x for that side. So I'm going to take 60 minus 2 x's. That gives me how much is left, but I want to divide that amongst both of these sides. So I'm going to have to divide each of them by 2. So you could leave it like that, or you could rewrite that as 30 minus x. So each of these sides have to be 30 minus x. Now let me kind of just put that in perspective for you. We're not going to go through and guess and check all of these. That would take us forever. But I just want you to see, let's say we let x be 10. Then to figure out the other side, we would do 30 minus 10, which would be 20. And then we would add those up, 20, 40, 50, 60. That does equal 60 yards of fence. Let's just say that we just let x be 12. Sure, why not? That's 24. You would do 30 minus 12. What I was about to say with the 24 is that you would divide it by, divided by 2. But then these side lengths would be 18, and then you would add those up, and it would still equal 60. So that's how we get our expressions. All right? Once we have those expressions, the x, and the 30 minus x, I think the easiest thing to do is to go to a calculator and to type it in the table function. So let me show you what I mean by that. First, I'm going to write out my equation. The area equals the base times the height. In this case, my base is 30 minus x, and my height is x. So I'm going to go to my calculator and type that in. So I pulled up my calculator, and I'm going to go to the table feature, and I'm going to type in my area formula. So 30 minus x times x. And I'm trying to maximize the volume. So I'm just going to start at 0, and this is not the volume, the area. This is going to represent the area. And I'm going to scroll down until I find the biggest possible area. So all of these are area possibilities. But notice right here, it goes from an area of 224 to an area of 225, and then back down to an area of 224. And if you keep scrolling down, these are going to keep getting smaller and smaller, which means the maximum area that I can get here is 225. And that's when my side length x is 15. So in this case, it asks what is the maximum area. That would be 225 yards would be my maximum area. Now, if I've completely just mind-blown you there, let's just try one more example. I think another example, instead of 60 yards, let's use 40 yards. So we're going to kind of do the same thing just one more time, and we're going to say that she has 40 yards of fence. So I'm still trying to figure out the area of the rectangle, so I know I'm going to use base times height. I'm going to let just these sides be x, and then to figure out the other side, my total is 40. I want to subtract off the 2 x's that I've already used, and then I want to divide that in half because I have to have it for the top and the bottom. So my expression here would be 20 minus x for the top and the bottom. Once I know those expressions, I can put them into my area formula, the base times the height. And then I can open up my calculator, go to the table button, and type it in. So 20 minus x. Oops, that is not what I wanted. 20 minus x times x. And then I'm just going to start back at 0. And I'm going to scroll through until I get the maximum area. So my area could be 19 or 36, blah, 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 all these different area options. Okay, so right here, my area starts going down. It gets all the way up to 100, and then it starts decreasing again. So that means that my maximum area is 100, and that's when my side length is 10. So my maximum area here would be 100 yards squared. All right, so I hope that helps y'all. Good luck on this quiz.